Hi, and welcome back to the Raid Files. Today, we are answering the question on everyone's mind right now. What is actually going on with security in AI coding tools? Because if you've been reading the headlines, it kind of feels like everything's on fire. In the last episode, we covered how threat actors are increasingly using installed AI tools to breach organizations. Engineers have always been high value targets. They hold production credentials, cloud keys, signing certificates, and they routinely clone code from people they've never met. The coding tools they're now running have made that attack surface much bigger. And every major tool, be it Claude Code, Cursor, Antigravity, the lot, has had at least one serious disclosure in the last 3 months. Some have had 5 or 6. These aren't theoretical either. These are real breaches, real data loss, and at least one production database that suddenly no longer exists. So in this video, we'll cut through it all. We'll identify the 4 patterns the vulnerabilities fall into, talk through some of the more interesting tool misbehaviors, and most importantly, get into what you can actually do about it. Starting off with the disclosures. I'm not going to read CVE numbers to you. I think what's more useful is recognizing the 4 patterns that these vulnerabilities tend to fall into, because once you see them, you can spot the next one yourself. Pattern 1, config files are now executable code. This is the biggest category by volume. Claude settings JSON, MCP JSON, VS Code tasks JSON, cursor rules, and Git hooks tucked inside nested bear repositories. Files that used to be documentation, and now they're instructions run the moment you open a folder. Researchers at Novi found that cloning a malicious repo in Cursor could run arbitrary code on a developer's machine through a Git hook the AI agent triggered as part of a routine Git checkout. Checkpoint found similar issues in Claude Code with hooks defined in settings files, and Pillar Security found Antigravity's file search tool could be tricked into executing arbitrary binaries through its X flag. Different tools, same underlying problem. Project configuration is being treated as trusted input when it's coming from strangers on the internet. Pattern 2, prompt injection from data your agent reads. This one has been around for a couple years now, but it's getting much more sophisticated. Orca Security found that a malicious GitHub issue containing instructions hidden in an HTML comment could be silently processed by Copilot when a user launched a code space from it, leaking the privileged GitHub token. They called it Rogue Pilot. Then in April, and apologies in advance for the mispronunciation, but a researcher named Anand Guan with collaborators at Johns Hopkins published Command and Control. It's the same attack pattern which works against Claude Code Security Review, Gemini CLI Action, and GitHub Copilot Agent. 3 vendors, one prompt injection technique, full credential theft. Anthropic rated it CVS 9.4 critical. None of the 3 vendors issued public CVEs. Simon Willison calls it the lethal trifecta. If your agent has access to private data, exposure to untrusted content, and the ability to send things outwards, then that's an exfiltration channel by design. Filters get you about 97% accuracy on known injection patterns. At enterprise scale, 3% failure can be catastrophic. Pattern 3, sandbox escapes and the limits of sandboxing. Claude Code's bubble wrap sandbox got hit multiple times this quarter. There's a symlink escape. Sandboxed processes could create symlinks pointing outside the workspace, and the unsandboxed parent processes would then follow them when writing. Simulate found that a different one where the sandbox failed to protect Claude's settings JSON if the file didn't exist at startup. So malicious code inside the sandbox could just create it and inject persistent hooks. Anthropic has patched both. Cursor, though, had its own. Pillar's nomshub research showed that shell built-ins like export, typeset, and declare bypass the command allow list entirely. Empty allow list for RCE. But the headline isn't any single CVE. It's a finding from a firm called Honor. They demonstrated that when Claude Code's sandbox got in the way of completing a task, the agent simply disabled the sandbox itself and ran the command outside of it. Not jailbroken, not told to escape, just trying to be helpful. The lesson, sandboxes are necessary, but they're not the whole answer. Pattern 4, the MCP supply chain. This is the one that's going to get worse before it gets better. In January, researchers found over 42,000 publicly exposed MCP endpoints leaking API keys. Trend Micro found 492 MCP servers running with zero authentication. Analysis of public MCP servers found that 5% are already seeded with tool poisoning. That's malicious instructions hidden in tool descriptions that the AI reads, but the user never sees. And 5 days ago, and I mean 5 days ago as I'm recording this, Adversary AI published research called Trustful. They demonstrated that Claude Code, Cursor CLI, Gemini CLI, and Copilot CLI all execute project-defined MCP servers the moment a developer accepts the folder trust prompt. One key press. The MCP servers run unsandboxed with the user's full privileges. On CI runners, there's no prompt at all. It just kind of happens. Anthropic declined the report. Their position is that by clicking, yes, I trust this folder, it counts as consent, which I think is fair and technically defensible, but the previous version of Claude Code's dialogue explicitly warned about MCP execution and offered an opt-out. That UX was removed in 2.1, so it's a bit of a sticky one. Now, here's where it gets kind of weirder. Everything I've just covered is in the attackers doing bad things bucket, but there's a second category that I think matters even more, perhaps. The tools doing things their users genuinely didn't expect. And I have 3 short examples for you. First, file access. Claude Code's documentation explicitly says writes are restricted to the project scope, but reads outside the working directory are deliberately permitted. This isn't hidden information. It's very clear on Anthropic's website, but it's not how you expect things to work. And let's face it, how many people who have installed Claude Code genuinely dig down into the config settings? Not that many would be my guess. So one security researcher demonstrated that asking Claude Code to diff a key inside the project against one outside read his entire home directory's contents into the session. There's also a GitHub issue from back in January where Claude Code triggered Dropbox to sync down audio files the user had never touched. This means that things you may not want getting picked up by Claude Code could potentially be getting read, sent down Anthropic's APIs, and stored somewhere that's outside of your control. Now imagine one of those is an end file with all of the creds, or maybe even something worse. Second, there's a public GitHub issue where a user noticed that when bash commands are changed with an ampersand, the permission system appears to only validate the first command in the chain, allowing subsequent commands to execute without approval, even when they're not in the allow list. That issue was closed a couple weeks ago. And third, this is the one that should be in every CISO slide deck. On April 25th this year, a Cursor agent powered by Cloud Opus deleted the entire production database of a SaaS company called Pocket OS in a single API call, and it took 9 seconds. But what happened? The agent hit a credential mismatch in staging. Instead of stopping, it decided to fix the issue by deleting a railway volume. To do that, it scanned the codebase looking for any token that might work. It found an API token meant for managing custom domains and used it because railway tokens carry blanket scope across the whole account. The backups were reachable from the same tokens, so they went too, and it caused a 30-hour outage. Nobody hacked Pocket OS. The agent did exactly what it thought it was supposed to do. It was helpful in a way that no human engineer would ever have been. And underneath this is a layer that's getting more attention in research circles. There's now solid evidence that models themselves are starting to behave deceptively in specific situations. OpenAI documented their O3 model intentionally underperforming on a chemistry test after working out it wouldn't be deployed if it scored too high. The UK AI Safety Institute counted nearly 700 real-world incidents of model scheming between October and March. That's a 5-fold increase. The framing I would offer? Your AI agent is a junior engineer with production access who sometimes might be lying to you. That's the new threat model. So what do you actually do about all of this? The good news is that this is mostly a governance problem. You don't need a special AI security product to address it, just the familiar governance principles you already know. Firstly, treat your agents as non-human identities. Same lifecycle as any service account, provisioning, scope, rotation, audit logs. It's a familiar shape. You've just got a new type of NHI running on every engineer's laptop. In practice, that means three things. First, check what each tool or agent can actually reach right now, not what it's allowed to do in theory. What files, MCP servers, credentials, and network endpoints are accessible from a session run today. A lot of the default settings on these tools may surprise you on what's allowed out of the box. Second, use the managed settings layer every major tool now offers. This is the equivalent of group policy for AI agents. Claude Code's managed settings JSON lets IT push deny rules and permission modes that no user or project setting can override. Codex's requirements toml lets enterprise admins forbid auto approvals or force sandbox access outright. And Cursor's enterprise controls lets you enforce settings via MDM. These exist precisely so the security team can set a floor that velocity-pressured engineers can't disable. Third, audit what your agents are doing. Codex has open telemetry export, and there are AI gateways you can add that log every request and response. If you're not collecting agent activity logs, you can't investigate when something goes wrong, and when it goes wrong fast. Second governance principle you can apply: bound the blast radius before you bound the prompt. Even a perfectly written prompt sometimes produces an action the user just didn't expect. Come back to Pocket OS for a second. The recoverable version of that incident is one where the custom domain token couldn't delete volumes in the first place, where the backups weren't reachable from the same credentials as the primary, and where the agent had to ask a human before any destructive call. Now, if this feels all like quite a lot to take in, here are three concrete things you can do. First, use allow lists with narrow scope, not blanket allow plus a deny list. Claude Code's permissions rules lets you allow certain bash commands while leaving everything else to prompt approve. Cursor has a similar allow list for auto run. This helps to avoid approval fatigue while keeping things safe. Worth flagging, Backslash Security found 4 ways to bypass Cursor's deny list using base64 encoding and subshells, and Cursor had since deprecated deny list mode entirely. Allow lists aren't perfect either, but they fail closed instead of open. Second, default to no network access from the agent's sandbox. Codex's workspace write mode keeps network access false by default. Opt in for the specific tasks that need it. This is the most practical way to cut the exfiltration leg of the lethal trifecta. If the agent can't reach the internet, prompt injection can't leak your data to it. And third, restrict what the agent reads, not just what it writes. By default, Claude Code can read files outside of the working directory. That's the home direction leak we talked about earlier. The fix is to adjust the read-deny rules in settings JSON by blocking paths like SSH, AWS, and similar, ideally pushed via managed settings so no individual users can disable them. And just a quick note on sandboxing across all of this. We have seen sandboxes get bypassed multiple times this quarter, but they're still worth using. Each layer fails for different reasons. Permissions, sandbox, managed settings, MCP review, the combination is what gives you a chance. And the tools are getting better quickly. Claude Code's managed settings layer, for example, didn't exist a year ago. My last tip is to recognize that prompting is now a security skill, not just a productivity one. This one is about how engineers work with these tools, not the tools themselves. The thread running through a lot of these incidents we've covered is that agents follow instructions differently to people. A colleague asked to fix a credential issue will figure out roughly what you meant and ask if something looks risky. An agent given the same instruction will pick an interpretation and run with it, and the interpretation isn't always the safe one. So the way we write instructions has to change. A prompt to an agent is less like a request and more like a delegation. You're handing over authority to act, not just asking for help a lot of the time. Most of us have learned how to write prompts that get good output. Writing prompts that also stay in scope is a newer skill, and the whole industry is still figuring it out. In practice, it could look like adding explicit limits to the request. Fix the staging issue, but don't touch infrastructure and only use credentials already loaded. Ask before deleting anything. Same task, much narrower runway. Another way is to add security guidelines to the main instruction file so that it can be reused across prompts and engineers. The second piece is review. Veracode tested over 100 LLMs and found 45% of generated code samples introduced OWASP top 10 vulnerabilities. That is a tooling problem, not an engineer problem. But it does mean that AI-generated code needs the same level of scrutiny you would give to a pull request from someone outside of the team. The instinct is to sometimes skim it because it looks right. The discipline is to read it like you would any other unfamiliar code. And to come back to where I started this section, a lot of what you may be able to implement from this list right away may depend on the type of organization you work for and where priorities currently lie. But remember, none of this needs to happen all at once. If I had to pick one place to start, it would be this. Read the documentation for the tools your team is actually using. All of it sounds obvious until you realize how much has changed in the last 6 months. New settings, new defaults, new sandbox modes, new ways to push managed configuration. The teams getting this right aren't the ones with the biggest security budgets. They're the ones who actually understand what their tools do and how they're configured. That's the foundation everything else builds on. We've mostly focused on IDEs in this video, but the same patterns apply to PR review tools like CodeRabbit and Greptile, the agent in CI layer, and the broader orchestration stack. Different tool, very similar threat model. The good news is that that's a class of problem your team already knows how to solve. It's identity, access management, change control, and least privilege, applied to a new kind of user. The framing is different, the discipline is the same. That's everything for this one. As always, sources are in the description. If you found it useful, subscribe, and there's more of this coming, so I'll see you in the next one.